Hey guys, everyone welcome in. Hopefully everyone's in the right place. Meraki offline, cloud management without the cloud. And I want to start today's conversation off with a story to kind of set the stage. It was 10 years ago, maybe a little longer than that. I was awoken in the middle of the night, Sunday night, 3 a.m. Campus police is calling me to let me know that 911 is down for the university I work at. Of course, this was my first on-call rotation, so naturally this is the call I would get. And as I drove into campus, this was the quote that kind of came into my head. Anything that can go wrong will go wrong. Police headquarters had redundant power UPSs, power generators, redundant connections to the core, even uniquely redundant connections to actual end user devices and servers. So I was kind of confused on what might happen. And that's what today's conversation is about, right? We're not talking about the good days. We're not talking about when things go right. We're talking about when things go wrong. So it's kind of unusual, right? I want you to consider that throughout today's presentation. And if you're wondering, it was a 4500 chassis that had a memory leak. So all I had to do was reboot it, save the day, nice and easy. So if you're not familiar with Meraki, you might at least know that it's a cloud-managed network solution. For a long time, it's been known for its simplicity, its ease of use, but there's a lot of things that go on behind the scenes of Meraki that make it resilient by design, but connected by the cloud. So that's going to be today's core message that I hope to leave you with. And who is this guy? My name is ChaseGleason. I'm a technical product leader within the enterprise business unit. That just means if it switch routes or broadcasts, or is a platform that manages one of those things, Catalyst Center and Meraki, I advocate for customers, our largest customers within Cisco, to our platform teams. I've been in networking for about 15 years. It's really easy, really lucky to cut my teeth early at the Cisco Networking Academy in high school, and I've been at a partner, a customer, and now at Cisco Meraki for about 5 years. I'm out of Richmond, Virginia, for any of those East Coasters out there. I love snowboarding, traveling, and DIY projects on my house. It's way too old and falling apart. Today's not your only opportunity to talk to me, so please leverage the WebEx Space app. Obviously, I won't be responding live, but we'll follow up immediately afterwards. Assuming we don't get time for questions live, I will be up here at the end, so please feel free to come up and ask any questions you might have. Quick agenda. First, we're going to get all on the same page on what we mean by cloud management, right? Meraki is what we use for network cloud management. Want to make sure everyone understands what that means. How does Meraki keep devices cloud connected? A lot of cool things behind the scenes that are less known, less documented than they should be. Then we're going to dig into those bad days. What do you do? What continues to work when Meraki goes offline? And how do I troubleshoot cloud managed networking without the cloud? So let's talk about planes. Bear with me on this analogy. Pretty basic, but I hope it makes it crystal clear. Within networking, we have the data plane. This is the bits and bytes, ones and zeros, the passengers and cargo on your plane. And what controls the data plane? The control plane. We made naming easy on this one. This is like your pilots, your autopilot, the spanning tree OSPF, the real-time control plane protocols that manage your network. What manages or tells the control plane what to do? The management plane. This is like air traffic control, airline headquarters. This is our SNP, SSH syslog. I could go into network platform, obviously being a huge part of this. I hope this really highlights, when we talk about cloud management, we're only talking about that top piece. Meraki did not reinvent networking. It did not reinvent the control plane or the data plane. That stays the same. And here, hopefully, you see if a pilot loses contact with air traffic control, the plane does not fall out of the sky, right? The plane continues to fly. So let's make it the shortest Cisco Live presentation ever. What happens when my Meraki loses connectivity to the cloud?
Nothing.
Your network continues to operate, right? It just continues to work. The plane continues to fly. But Some of you engineers out there might be like, well, Chase, what exactly continues to work? What doesn't work? So there's a little asterisk on there, and that's what we want to dive into today. What are those things that don't work? How can I make my network the most survivable possible? But before we go there, I think especially post-COVID, it's important to ask yourself this question. What is your network without the internet? So many networks out there are really internet-style cafes, right? You think about your small, ubiquitous remote offices, and if most of the business applications your business is leveraging are internet-based as well, what value is there in providing a bunch of redundancy in your management plane if it doesn't matter if your network isn't as helpful without the internet? So just an important, don't over-rotate on every small remote office does not need to, take all these survivability concepts into practice. But there are a ton of networks that still want to maintain operations even without the internet. So retailers want to cache credit card transactions, warehouse and distribution centers want to scan inventory, and large campus environments still actually have local data centers that will provide local services. So let's talk about staying cloud connected. What are all the things that Meraki does natively in the background to make sure that your devices never lose connectivity? First, let's talk about and define what we mean by the Meraki cloud. It's actually a set of multiple clouds or clusters. We have our Meraki.com cluster, which includes a North America, Europe, and Asia Pacific region, as well as our geoclouds, Canada, China, India, and Meraki for Gov. These are all separate, totally distinct clouds from one another. If you scroll down to the bottom of the Meraki dashboard, in the footer, you will see your data for this organization is hosted in, and then the region or geocloud that your Meraki organization lives in. Now, Meraki Cloud Connectivity, or Next Tunnel. This is what happens when all your devices are claimed within the Meraki dashboard. They'll immediately reach out leveraging this tunnel. What is it? It's a TCP 443, TLS 1.2, AES 256 encrypted, FIPS compliant, leveraging your trusted anchor module certificate secure tunnel. AKA, it's a really fancy HTTPS tunnel. Pretty nice and easy. What's also great about this is Next Tunnel front ends the Meraki dashboard, and it does this, at least in our commercial cluster, with just 3 easy subnets. So if you need to add allow lists out there, this makes that nice and easy. But there's more behind the scenes than just a single tunnel. Next Tunnel is actually made up of a primary and secondary tunnel over both IPv4 and IPv6. This goes back to your shard. Your shard is your piece of the Meraki network. It is shared, but it is leveraged across 2 disparate, physically dispersed data centers. And this allows you up to 4 potential paths out to the Meraki dashboard. Now, the other cool thing about this is even if IPv4 goes down, your IPv6 networks are still going to work, and we're actually starting to see situations where Meraki stays up when everything else goes down just because we're natively supporting that redundant capability. So when you claim a Meraki serial number or cloud ID, you get a secure tunnel and highly resilient connectivity to your network management. And that's nothing to just sniff out or put away. That allows a lot of flexibility without you, the network engineer, to need to worry about. If you try to stand this up yourself so you can understand how important this can be. But it is more than just TCP 443. There are many services that exist outside of Next Tunnel that's really important to understand. So in particularly on our MX or our firewalls and SD-WAN appliances, we have security services like AMP, Talos, Umbrella. Authentication, and you're going to see a theme with this. Radius and LDAP is available outside of Next Tunnel. Of course, any networking, if you're doing like auto VPN and SD-WAN, IPsec tunnels, or any telemetry, SNMP, syslog, NetFlow, all of that needs to be available outside of Next Tunnel, either outbound or inbound. Same thing with the rest of the lineup. MGs are cellular gateways, can ping outbound, so you want to make sure that that's available. Switches will allow you to do radius authentication, NetFlow, syslog, and SNMP. APs have a little bit more with LDAP authentication, Umbrella, and MQTT. With cameras, having a couple of separate services for cloud streaming, cloud proxy, and cloud archive, with real-time streaming protocol for third-party NVR support. Now, you've probably seen connection monitor at the bottom and mentioned several times in some of these slides. If you've ever done a packet capture on a Meraki device, you see it's kind of noisy. Well, this is what's happening in the background. We're going to ARP, ping, DNS, and for MXs even use HTTP to understand our outbound connectivity. So obviously we need layer 2 adjacency to our default gateways. This of course will include neighbor discovery for IPv6. We're going to ping outbound just to make sure we have routability. Next tunnel does require FQDN resolution, so we need DNS. And MXs will go one step further because they actually use this connectivity monitor for WAN failover. So they'll actually do outbound HTTP gets. Now, you might be saying this is a lot for cellular, so these frequencies do change for the MG or an MX leveraging cellular connectivity. Now, I went through all of that pretty fast. I didn't mention any ports or protocols or IP addresses, and that is because right within dashboard, all this information is available to you in the help icon, firewall info, and you're going to see a custom set of firewall rules that you need to implement to have a successful Meraki deployment. So this is probably the first step to staying cloud connected is make sure you have all the outbound connectivity you might need, and we make it as easy as possible to ship this CSV over to the security team to implement for you. I'm sure with no further questions than that. Next up, we have maintaining manageability. I'm going to tell you another story, and I promise I've learned a lot since these days. But as a junior engineer for the university I was working at the time, I was in charge of deploying a small site, but it was like 2 hours away, 10 switches, should be nice and easy. After driving 2 hours back, got a call that all the surveillance cameras were down. No problem, really easy. I'm just going to add the surveillance camera VLAN to my uplink. Sounds like I'm not the only one who's made this mistake. So this is a really bad day. You're either calling someone to reboot your switches or you're padding around for wherever you put your keys, right? There's not a lot of in between. And so maintaining manageability is number one, right? We can fix ourselves out of a lot of scenarios, but your heart drops when you don't get that return prompt. So Meraki has a couple of resilient cloud connectivity mechanisms that help prevent these kind of situations from happening, right? You can still put yourself in a bad spot, but these two are going to be really helpful. The first one is what we call safe configuration. Now, the formal definition is if the device has connectivity to the cloud and hasn't rebooted for 30 minutes following a configuration change, the configuration is marked as safe. Said another way, as long as you don't lose management within 30 minutes of a config change when we don't reboot, it's pretty safe to say that, that didn't break manageability. So the whole goal for safe configuration is to be able to quickly roll back any changes that might have been highly impactful to the manageability of that device. So it's meant to revert change, as well as firmware, and even reboot a device after a prolonged period of loss of cloud connectivity. Now, you might see this from time to time if you see configuration is out of date. That means the device hasn't checked in, and we're assuming at that point that that device has reverted back to the last known good configuration. But it's not perfect, and it's not fast, so we want to kind of talk about a little bit some of those nuances. Firstly, it's only management aware per device. So if I have a distribution switch, and I break connectivity by making a change on the distribution switch to all my downstream access switches, we're not going to revert back configuration on the distribution switch, right? Because I have manageability of that and I can still fix it, right? Importantly, my hands aren't completely cut off like in my example. The other thing is we're not going to fix unsafe configuration. So while this is a smart feature, you still need to make sure that you have an understanding on when configuration is broken and to be able to fix it. If not, you're going to get what I call the Christmas tree effect. The device is going to go offline. It's going to revert to its last known good configuration. It's going to check in and realize, oh, I have config to apply, and download that bad config again. So it's really important that you identify this and revert your unsafe configuration from dashboard. The next thing is there's a timers on this. So we want to make sure that for switches and MXs in particular, that you stage your configuration for at least 30 minutes when you're doing staged deployments. If not, you can run into a situation where you do all this work to bring it up, make all the configuration changes. If you just pull power, it's not going to stay on the switch. So keep those devices up for at least 30 minutes when you're doing stage deployments. The next connectivity mechanism we have is called uplink auto configuration. And those of you who have deployed Meraki have likely seen this in some form or fashion with messages like this, or this, or this. This mechanism's whole goal is to find an interface and IP address that gives it cloud connectivity. Now, this ends up looking like a lot of DHCP and VLAN fallback. So this is really helpful in those days where you might accidentally mistype a management IP address. Instead of losing connectivity, the device is going to temporarily apply that, realize when I use that management IP address, I don't get out, and then go back to its last known VLAN, DHCP address, etc. Switches will go one step further and they do what we call VLAN hunting. So it's actually going to look for incoming tagged traffic, discover what VLANs are actually active and attempt DHCP on them. So that can even happen midway through operations. If you have a management network outage, you might see your switches start DHCPing on random VLANs. It's expected because we're trying to get out no matter what. And lastly, MXs will do uplink failover, so no matter what, as long as there's an option out, those devices will try to use them. So that looks like failover from WAN 1 to WAN 2, even to WAN 3, and SIM failover on MGs. So just a quick chart on how all this kind of comes together, the different periods in which reboots, safe config rollback, or what uplink auto configuration options there are out there. So hopefully we see that we have many different resilient cloud connectivity options. First, with Next Tunnel, right, we have a secure tunnel that goes back to a redundant shard. Make sure to allow those outbound Meraki IP addresses. This is the first thing we can do to help prevent ourselves from losing cloud connectivity. Safe config rollback. Make sure to fix any unsafe configuration and stage those devices for at least 30 minutes. And uplink auto configuration. Really using a native VLAN with DHCP as your best friend, at least to have the quickest uplink auto configuration experience. There's a really cool session tomorrow, 14:01 at 2:30, that goes into designing switch networks on cloud native iOS XE that shows how we've brought all of these processes that have been native to Meraki into our iOS XE based devices managed in the cloud. So hopefully we're seeing that Meraki is resilient by design, connected by the cloud. So next up, we have offline operations. Now, this is not a real story, but I know it's one that's been out there, right? You're looking across the street, there's a construction site, and you see the network outage machine 4000, the backhoe come in and rip up the supposedly redundant last mile internet service provider that's actually using the same last mile fiber path up and out, and now you're going to be an extended outage period. You probably want to have an understanding of what's going to continue to work within your network. The first thing that probably comes to mind is authentication, right? This can have the most immediate impact to your operations. So first we want to talk about what authentication doesn't require any cloud connectivity, at least strictly. And you probably saw it in our first set of slides, that the Meraki devices actually source all of the Radius or LDAP authentication directly from their management IP addresses. So you're going to see that Radius, LDAP, even wireless authentication with local splash page access is all totally survivable. Of course, this actually also includes IPSK without Radius. That's local. Appreciate key and opportunistic wireless encryption is also completely local. Probably more importantly is to consider what authentication services strictly require cloud connectivity. This is going to be anything proxied through Next Tunnel. So Radius Proxy, it's actually a pretty cool capability where we actually take your Radius traffic and proxy it through Next Tunnel. So that way your source Radius traffic is from a handful of cloud IPs. That goes through Next Tunnel. So if Next Tunnel goes down, that goes down. The same goes for Meraki authentication. So when you're logging in with your Meraki username and password for wireless connectivity, as well as Access Manager, our cloud network access control. Meraki splash pages are actually hosted on the internet. They don't require next tunnel, but one thing we're going to assume here is that when we lose cloud connectivity, we're also losing internet access, so just be aware of that. And importantly, any non-local authentication server. So unless you have a local ICE-PSN or a local Radius server to your site, right, you're going to want to think about how your authentication can be survivable. So let's talk about it. What kind of survivable authentication mechanisms do we have available to us? And I'm going to put this in 3 main categories. Remember, and so this is going to remember our existing authentication sessions, basically caching. This is the easiest thing we can do because we can just keep on going with whatever the current authentication state is to allow us to maintain operations through an outage. Next is contain. We want to set predictable fallback access. So if a device wasn't previously authenticated, where does it go? Does it go to guest VLAN? Do you have some sort of critical local services that should be available to that device? And then lastly is decide. Do we fail open or restricted? This is really important for anything that has a splash page or captive portal on it, because we want to understand what happens to that splash page if it doesn't have cloud access. First thing is going to be radius caching. Really simply, in your access policy for switches, you can simply enable the caching feature and set a timeout for it. Importantly, this is only supported on Catalyst-based switches. This is both for the CS and the cloud-native iOS XE firmware that's 17.15 or greater. And for switching, when we discover that you match the settings or attributes of an existing session, we're just going to silently transition that port to forwarding. Most operating systems are really cool with that. Windows is not. So make sure, if you're going to leverage this feature, in the supplicant of Windows, there's a enable fallback access checkbox that you need to have enabled because Windows does not like not seeing an EAP success message. For local authentication on an AP, you're going to see kind of a common theme here, right? We just need to be able to set the credential timeout. How long do we want that session cache to be available? And really cool, this is one of the main ones that allows us to support both password and certificate-based session caching or authentication caching. We have a newer feature called extended local authentication. Local off fallback is what it's called in dashboard, and what I like to call it is wireless radius caching, because that's what it is. We just have 3 names for it for your confusion. This allows you to cache EAP TLS, so certificate-based authentication, and MAB authentication. When you do this, you are going to see your APs are going to start to monitor radius, and this allows it to understand when radius is up and down. So you'll see a Meraki user start to be sourced from the AP and test whether radius is available from that access point. Really important here is this does not fake its EAP transition. So it is going to send an EAP success message, and that is going to require a radius certificate for that. So you're going to want to make sure to upload a trusted certificate for the AP to be able to help in that transition. Again, this is a newer feature, so definitely check out the supported firmware for this. For Access Manager, now Access Manager, for those of you that are unfamiliar, is our cloud-hosted radius or network access control features. You can do the same thing. It is totally survivable. And again, it's called extended authentication. So this supports certificates, but not additional rule evaluation. So this is just going to be able to say, do you match the criteria, but we're not going to go through all of your authentication policies. Really easy here. We're going to go to both the certificate under Access Manager and Enable, as well as under Access Control, extend local authentication. So next up, now we're on our critical authentication VLAN. And here is where we're going to start to see setting that predictable fallback access. So here, again, under my access policies, I can just define what VLAN I want devices to go into when we discover that the radius server is not available. So this is also going to enable radius monitoring. Again, these devices need to understand when radius is responding and not. So you will see this Meraki _ 802.1x _ test device hit your authentication devices radius server. that is expected. When you enable this, you'll also see an option for port bouncing to be enabled or disabled. It's enabled by default. An important caveat here, MAB devices do not know when you switch the VLAN on them. So if they were up and working and needed to fall back and use the critical authentication VLAN, say going from VLAN 50 to 100, that would be done silently in the background. They don't know that they've switched VLANs and therefore stay with their old IP addresses. So you definitely want to keep port bounce enabled in almost all cases so that that MAB client can re-IP address. The other two call-outs here is it's best practice to have your data and your voice VLANs on separate VLANs for the critical authentication configuration. And there's a couple of hidden slides that you'll see in the PDF going into more details on how this feature interoperates with several other of the guest and failed authentication VLAN feature sets. Next up is we have smart port automations. So this is a newer feature available on our NS17 and Cloud Native iOS XE feature firmware on 17.18.3. Here, you're going to be really leveraging two feature sets. If you're familiar with Catalyst devices, you've heard of these before. Interface templates and service policies. So this allows you to first set a port profile or an interface template within the Meraki dashboard. So you can pre-configure and say, I want all VLANs or I want all APs to have a specific set of port configuration or interface configuration. Basically, you can now create interface templates within the Meraki dashboard under the organization switch ports section. The next part where it becomes cool and has automation is where we use service policies. This allows you to define an LLDP system description and Mac OUI where you can use wildcards to say, I want all ports that match the LLDP description of Meraki access point or AP with a certain Mac OUI, apply this port profile. So what's great about this is actually configuration that's pushed down to the switch and totally local. So while it's not strictly authentication, this allows you to have predictable understanding about how your ports are configured, even without cloud access. So this is a completely survivable feature since it's all the configuration and logic is done local to the switch. And lastly, we have splash pages. Now, we actually technically have splash page on both the APs, which hopefully everyone's familiar with, and the MX. Here, you're just going to want to be able to set the controller disconnect behavior, right? What happens when I cannot connect to the Meraki dashboard as the controller in this case? And this also applies to splash pages that use LDAP or radius authentication. So this allows us to have a good understanding if we want to fail open, which is what is default, or fail restricted. What's great about everything we just talked about is while that all pertains to offline scenarios, I know ICE or your radius service has never gone down before. It's also really important for those scenarios. So going beyond just offline operations with Meraki, it's best practice for authentication survivability. Next up is our backhoe is still pulling up all the fiber out of the ground for us across the street, and you realize it's going to be some time before you actually get any insight into your network. What kind of local telemetry can you get from your devices? So that's what we want to talk about next, right? If you're going to have an extended outage, you want to be able to get some sort of insights. So first we'll talk about what telemetry is available to you offline. The first one we're going to talk about is probably the most uncommon out there, and it's called MQTT. This is available on our APs, our cameras, and the sensors will upload that through whichever gateway they're using to connect. This will send a variety of information. So for sensor, it will, temperature, humidity, whatever the sensor data is. Cameras will send object detection information, and APs will send real-time location service information. It's a publisher, subscriber-based model, but it's completely local. So if you're using any of these feature sets or using any of the logic that you see in cameras or sensors, this is a really good way to have that available offline, and it's way faster than proxying anything through the cloud. So if you're leveraging any of the sensor data, any of the camera information, or need real-time location services, consider MQTT. Next up is we have NetFlow. This is available on our advanced license of the MS switches, as well as our MXs. And where we'll talk about things the most is syslog and SNMP. Now, SNMP, for local SNMP within the devices, you'll find under the network-wide and general section of dashboard. And we're first going to see that we have SNMP v2 MIBs. Now, it's called v2. It's available on v3. This is your core set of MIBs for the device. So you're going to see uptime, system name, all the basics. We also support interface MIBs or if MIBs, and this is where you're going to see bits and bytes in and out, errors, discards, all the interface statistics we know and love for all the management devices out there. This is available on all of our switches, both MS Classic, CS firmware, Cloud Native iOS XE, MX, and MR, including the radios on the APs as well. An important call out, while not a new feature, it's a newer feature capability of dashboard. We do have SNMP v3 capabilities, and I call this out because we are starting to deprecate version 2 of SNMP. I'm sure everyone's aware that security is top of mind, and Cisco is trying to secure our devices as much as possible. Now, with all deprecation, this is going to take time, so I'm first talking about it here. I'm sure you'll hear more sessions mention some of it. And you'll eventually start to see messages within dashboard warning you that it's going to be deprecated. It'll be some time before it's truly not available, but if you're not using SNMP v3 today, I would consider using it in the future. Next up, we have syslog. So you're going to find this in the same section, network-wide general reporting. And there's a bunch of different features and capabilities that you'll see within syslog. Security events, flows, URLs, air marshal, for wireless intrusion prevention. In general, if you're talking about offline operations, the main thing we're going to want to look at are the event logs. This is pretty much identical what you would find in the network-wide event log section of dashboard, and will give us all the insights we need. An important call out here is we will start to see encrypted TLS show up within dashboard as a configurable option. This is a newer feature that we've released, and it's only available on MX-only networks if you have an MX that is set to 26.1 or greater. We do plan to bring this to all the devices, so you'll see this come to APs and switches in the future, but don't get confused by this today. If you do see it checkbox enabled, it might yell at you if you don't meet those requirements. So what telemetry requires cloud connectivity, right? What are the things that are going to be completely not survivable? Well, for your confusion, we have something called org-wide SNMP. If you go to the organization settings page, you're going to see this section. This has nothing to do with SNMP local to your devices. This is only if you're pulling inventory information and other alerting information from dashboard itself. We see that because we're going to snmp.meraki.com to pull that information. This does not configure to your devices at all. There's also SNMP traps for login attempts as well. Again, that's all cloud hosted. It has nothing to do with your local telemetry. And we say this because this can be very confusing if you're not used to Meraki, so I want to make sure we call it out. Lastly, of course, Meraki has a lot of good telemetry sources, APIs, webhooks, et cetera. Those are all cloud hosted. There are no local versions of that, so that requires cloud connectivity for all of it. Next up, we have alternative management interfaces, or AMIs. Here, if you go to network-wide in general and scroll all the way to the bottom of the page, you're going to find a section called alternative management interfaces. By default, all management traffic, including everything we just talked about for authentication and for telemetry, is sourced from the same management interface that Nextel is. And the first thing your security team is going to say, hey, Chase, I don't like that my syslog server also has internet access, et cetera. So this gives you the ability to separate the Nextel management network from the other management protocols that are available. So here it's scoped network-wide, so all your switches and all your APs need to have the same alternative management VLAN rather, and you can select what protocols you want to be available or sourced from that VLAN. Last call out here, is you do have to statically set your IP addresses. Now, this can be done programmatically, so please don't go click 1,000 times to do it, but important to call out is that DHCP is not supported. Next up is alerting and insights. So you might want to have a good idea about when your actual Meraki network goes down. If you're not familiar with already, you go network-wide alerts. You can set on what frequency for what products you want to get an alert for. Now, it usually takes between 1 to 2 minutes for you to actually get an alert or an offline or unreachable device in dashboard. And if you have an extended outage, you might actually see some event logs and other telemetry information once the device comes back online during the outage. That means that there is some amount of information that is actually buffered and stored locally on the device. But that drastically changes from device to device, firmware to firmware, how many clients are connected, et cetera. But don't be surprised if you're like, hey, my device was offline at midnight and I see events from midnight. How'd that happen? It's normal and expected. Another pro tip here is to leverage the connectivity or the historical devices data graph, so you can actually hover over this and see exactly when connectivity changed. It may be sometimes hard to see at the very bottom there on like what exact timeline did things change. What can be really cool here, specifically on access points, is you can understand what the AP was doing even when it was offline. So as we've talked about already, we know that even though we don't have cloud connectivity, the AP is probably still broadcasting its SSID and still serving clients. So if you go to the device health page in historical AP reboots, you can see even though there was no cloud connectivity, the device actually stayed powered on except for a small period of reboot. So this can help you write those after action reports, get some better understanding about what happened to an access point even during an outage. And APs actually won't always broadcast their SSID. There are certain circumstances when the AP is going to prevent that from happening. So the first part is when there's no management IP address on the AP. So this has happened several times when you see an AP reboot during an outage. If there's not local DHCP available, it will not broadcast any SSIDs. Next up is if you have a tunneled SSID. So if it's going to an MX or an MCG, and that destination tunnel, MX or MCG is not available, we're not going to broadcast that SSID. And lastly, this is a more obscure one, but important to call out. If you're using NAT mode and not allowing local LAN access, and there's no cloud connectivity, we're not going to broadcast that SSID either. And if you see a theme here, if you're going to black hole traffic, if you connect to the SSID, we're not going to broadcast the SSID. So this is a way to prevent clients from connecting to essentially nothing. Another important call out for APs is there are some cloud services or services that APs consume that are 100% cloud connected. AI-RRM or Auto-RF and Air Marshal are all cloud connected features. So that means if you have a really long extended period of time and you're getting those syslog alerts letting you know when things should change, you won't see power levels or channels change over time because the APs do require cloud connectivity for those features. But in general, APs are very, very survivable. We've seen clients go through multi-week outages and still have local services available. If you're in bridged mode, that's because APs will actually locally share the client database or fast transition information through these broadcast UDP ports. And if you're tunneling, as long as the tunnel destination is available locally, your AP is going to be just fine. Both for the MX and the MCG, we'll attempt to try those connectivity mechanisms locally. So even when you have a backhoe across the street pulling up all your fiber, you can see that Meraki is resilient by design and connected by the cloud. So next up, our ISP finally came in and has put a bunch of fiber together and has guaranteed you that the network is back up for 100% for sure. You might have to do some troubleshooting without the cloud to prove them wrong. So we want to dig into how do I troubleshoot devices? How do I bootstrap my cloud managed devices and get them back up? The first place you should go is the device status page. Now, this is not status.meraki.com. If you're not familiar with status, cloud.meraki.com, you should go there. That's our status page for our cloud network. And is important to subscribe to. The device status page is our local console for cloud managed devices. It's web only, and you can get to that either locally by plugging into each device or remotely by going to the management interface. Now, if you're used to Meraki, you might have seen some changes here. As we move to cloud native iOS XE, you're going to see the look and feel change a little bit, but only more capabilities are being brought into these device status pages. A great example of this is the Meraki Campus Gateway. Here you can see that not only do we have the core fundamentals of what a device needs to connect to the cloud, but we see connected access points, clients, and more. So our local device status page. This is available to us when we're physically connected to the device. So that means you're plugged into any of the front LAN ports on a switch, MX, or MG, or any of the SSIDs on an AP. Some devices have a dedicated out-of-band management interface. This is your classic Cisco management interface. It's really great because it has DHCP and plug in and go, but please don't plug this into your production network. It will hand that same DHCP subnet out to random devices. Don't ask me how I know. It will cause havoc. So it's not your normal Cisco management interface. It's meant for you to take your laptop, plug in, your laptop will get a special IP address and allow you to get to this local status page. If you're connected to the device locally, you can also go to any of these local status page DNS locations. And for 1,000 different reasons, DNS is not going to redirect you appropriately, whether you're using secure DNS, you have security policies, whatever it might be. You can always go to these special IP addresses that are available per device. Next up, the remote device status page, or RSP, is the same thing as the local status page, just available via the management IP address. This is both for IPv4 and IPv6. Now, last part's important because IPv6 can seemingly magically turn on in some networks depending on who your ISP is. So just be aware of that if you do enable remote status page. It is off by default. And while it's the management IP address for most devices, it is also all the SVIs that you define. And on the MXs, this includes the WAN interfaces. So that's going to be important when we talk about security. And speaking of security, I'm going to stop here for a second before anyone misses this one, because this is important. We've seen a lot of pain with this one. Last August, if you didn't already have a password set for your device status pages, we randomly set one for you. It was really nice of us, but it was due to some EU Red regulations and security reasons that we've done that. And while we've improved security, you want to go set a local device status page password if you haven't already. So by default, your configuration for a new network is going to be local status page enabled, remote status page disabled, and that admin password randomly set for you. Now, you're going to see us move to HTTPS. If you've seen device status pages before, they weren't. That just means you're going to have to click through those scary self-signed certificate messages. And when you set that password, it is not visible afterwards. I know there's that show button right there. After you set it and you refresh the page, it does not show you again. So be sure to, when you set this password, you put in LastPass, whatever your local status page is. A friendly tip, this is not secure, but if you're for your labs, there's a notes field on the admin page that you can put any text into to remind you what that password might be. Now, there are still default credentials. So if you factory reset a device, or what the password would be if it's out of the box, it's just going to be admin and then the serial number or cloud ID as the password. If it's older, you might have to use the serial number as the username with no password. So one of the things you might be asked from your security team about securing these device status pages is making sure that no one from the internet can log into them. That should be done pretty easily under the security and SD-WAN, firewall and WAN appliance section. There's a dedicated place to set an allow list for what IP addresses should be able to get to the MX's local status page. This is particularly important because, again, they're available on those WAN interfaces. Switches, they don't have a dedicated section for this, but we do have a switch ACL where we can easily allow all the source subnets that we want to get to our management interface and deny the rest. So there's a couple reasons why you'd be getting into the device status page, and one of the first ones is just general configuration, right? How do I set an IP address on something if I don't have DHCP? That includes not only VLAN assignment, but also web proxy. You might need to set some minimal amount of LAN port configuration, so admin up and down, VLAN access trunk information, or maybe you're statically setting a link speed or negotiation. That is all available. And then APs actually have a site survey mode. So this allows you to do a site survey as a stick, set your channel width, channel, and power level. Lastly, we find ourselves in this bad day. We need to be able to just have general troubleshooting. What can that device get to? And what's great is we talked about that cloud connectivity, monitor capability. If we can ping, ARP, or DNS, and that's going to be front and center. So if a device cannot or is not passing any of those tests, those are going to be the first thing it tells you. If not, that just means it can't get out on TCP 443. So we're going to say something's not right. This more or less either means that you're blocking it, or another common one is SSL inspection or decryption. It's a common one that will get you on that. Lastly is getting out-of-band logs, or what we call the support data bundle. This is basically your show tech for Meraki. Now, this can take some time to generate, I'm sure, as you're familiar with show techs, but it's really crucial to capture this information before you do a reboot or a factory reset or tech has nothing to troubleshoot. So even if you're in a time crunch, definitely log into your device status page and try to grab this whenever possible. There are some cool device-specific troubleshooting capabilities. So on an AP, we have a bunch of client connectivity data available. So you can see the client's RSSI, its data rate, its IP address. So you can actually leverage the device status page as a troubleshooting tool. You'll also get general radio utilization, AP neighbors, and what's now deprecated on our newest versions, there is a speed test that's still out there in some of the older firmware versions of the access points. MGs will actually give you a dedicated diagnostic module that allows you to troubleshoot why is my MG not connecting to the 5G or 4G band that I expect. This is really helpful because troubleshooting cellular is not fun. And lastly, switches will give you a good amount of details on the switch port status, link negotiation, bits in and out, and even some packet capture capability. Lastly, we've talked a lot about cloud native iOS XE. So if I have iOS XE, why can't I just log into the console? Well, for the new Cisco smart switches, they're actually going to first boot in a global boot scenario, or what we call a global boot scenario. This means it has not yet picked if it's going to be cloud managed or locally managed. That means you have console access. So it's really cool. You can go through and connect to your 9350 or your refrigerator size 9610 and watch that boot up. Just know if you do interrupt that process, you will have to manually type in Service Meraki Connect or Cloud Management Connect to get that to work again. But you do have visibility. And this is actually the case on all Catalyst-based devices, even in cloud mode. So if for whatever reason the local device status page isn't coming up even through a reboot, you can still plug into that console port and get normal boot logs that you would see for any iOS XE device. Also importantly to call out here, much of what we talked about is only for configuration source cloud or config cloud mode. Configuration device mode, you still maintain all console and all SSH access. There's no local status page on configuration devices. Really hope to see some more capabilities coming to the console within the coming year, so definitely stay close to cloud native iOS XE and console access. So with offline operations and troubleshooting, we have local telemetry, SNMP and syslog, can really help you in that bad day for those extended outages. We have survivable authentication. This allows us to remember and keep those cached credentials and sessions, allows us to set predictable fallback access, and set the status page, or sorry, the splash page behavior. And lastly, our device status pages. You're really going to want to make sure you have an understanding and know how to get to these pages ahead of time, because trying to fumble through during an outage scenario is not going to be very fun, and be able to get to those important data bundles. So I've done a lot of talking and not a lot of showing. So I want to dig into a quick video demo that's just going to go through what using local telemetry looks like and how to get to those device status pages. So hopefully that is playing. So here, where we've talked about mostly, we're going to go to network-wide in general. And if you might notice, if we haven't talked about this yet, this is all sourced from Cisco Cloud Control at first, so the same look and feel. Here we're going to scroll down, and we're going to get to device configuration. You can set your remote status page, and that nice purple banner is reminding us that we might have randomly set your device status page password. Here I already have mine set, ready to go. Scrolling down a little bit more, we have reporting. This is the core part of what we were looking at today, where we have the syslog servers available to us. We can set what roles we want. So if you want a local-only syslog server for troubleshooting, you can set all the event logs for that. And I have SNMP, which is going to be SNMP v3 in this case, with security parameters. Lastly, right below that, it's kind of small, but the NetFlow is shortly after that. And since we're already here at that very bottom of the page, we have that alternative management interface. So really easy to enable for all the switches or all the APs in your network, and select what protocols you want to be in scope. Next up, we want to kind of actually look at what all this information would look like. So here we have a switch. I have an uplink on port 30. And just like in dashboard, right, I can scroll down and see, the usage of that interface over time. I'm going to even look at, I have I think port 1 here labeled as front door camera. I see the usage over time. We can get that core bit of essential information even in offline telemetry. Same thing with an access point. So here I just have some free open source tools with Grafana and Prometheus. I have an overview of all the bits and bytes coming in and out of my switch here, and I can do that at an interface level detail. So here you'll notice I actually have that port 1 front door camera showing when I'm streaming and when I'm not streaming, getting you that essential bit of information. And we'll take a look at our uplink interface here in just a sec. So the idea here is you would be able to spin this up in some sort of offline compute, Raspberry Pi locally, or even on a 9300 with its container capabilities. Really cool here is we can actually see a lot of details from an access point. So AP0 is 2.4 gigahertz, AP1 is 5, and AP2 is 6 gigahertz. So we can actually see from our wired interface coming inbound, outbound to our 5 gigahertz radio, all the data coming in. And lastly, not the most searchable, and this is definitely nowhere near as cool as Splunk, we do have syslog ingestion available to us locally. Again, we're just trying to make sure we can get back up and troubleshoot. So this actually lets us know that an SFP was plugged into a specific port. Again, all hosted on some really lightweight local containers to help us get through an outage scenario. Next up, we're going to actually look at some device status pages. So this is going to be for a Catalyst-based switch. I'm going to the remote status page. And here we're going to be able to see the essential information on the health of the switch. So nice green checkbox, it's easy. I can see what network it's claimed into, its model number, etc. If I need to set a static IP address, I can do that easily, or generate that data support bundle at the bottom. And lastly, we can see what port admin status, operation status, access policies, tags for if it's like a port channel, and statically set the link negotiation. So the core capabilities you would need to configure a switch are there for you. And lastly is going to be our access point. So here we can see my current connected wireless data rate and RSSI, some of the radio utilization, what the IP address and other information I'd use for connecting out to the cloud with this access point. Some of the neighbor information, so if you kind of want to get a rough idea of where it is physically, and that uplink configuration. So not only the basic uplink, but also the HTTP proxy and that data support bundle. So anything that can go wrong can also go wrong Friday afternoon or Sunday at 3 a.m. And this is all to say that if you've been on call, you understand that these outages, these bad days are not going to happen at the best case scenario. So I want you to have a plan and consider these key takeaways. Check out your outbound firewall rules. This can be an easy way to prevent you from having an errant offline call when security makes a new rule change. Consider local telemetry. It's really easy to set up SNMP ahead of time, even if you're not using it today. That gives you some more options down the road. Survivable authentication not only helps you in those offline cloud scenarios, but also for any issues with your authentication services. And for your device status page, please go set your admin credential for there and prevent yourself from not being able to get into those devices. Much of what we talked about today is fully documented throughout many different pages out there, so hopefully it was helpful to correlate all this together. You'll see several hidden reference slides, and any of these blue links will take you all to the public documentation that's out there. And I hope you guys can see that Meraki is resilient by design, connected by the cloud. I really appreciate everyone coming out today. Hopefully taught you something new. Please complete your session evaluation. I want to call out, I did not say the words AI once, and so I think that deserves 5 stars, right? Tomorrow at 2:30, level 2 Oceanside C, breakout session 1402. Thank you guys, appreciate it.